Hi, it's me. Are you there? Oh, hey, you're there. Oh, okay. Let's start video 25, binomial distribution table. Let's get this bread. All right, so what we're looking at here is a binomial distribution table. Binomial means either kind of win, loss, yes, no. So everything we're dealing with here will be either a win or a loss kind of situation, or something either happens or it doesn't happen. Now, here's our situation. We win. It's almost like we're playing a gambling game. We win if you flip a coin and you get a heads, and you toss the coin 2 times. What's the probability that you don't win? You win once and you win twice. Well, let's actually solve this problem without looking at our binomial distribution table. If you toss the coin 2 times, what are your options? You've got heads, heads. You've got tails, tails. You could do a heads, tails, or a tails, heads. And again, remember, you win if you flip a heads. Okay, so what's the probability you don't win? Well, the only case where that happens is tails, tails. So that's 1 out of 4. What's the probability that you win once? Okay, well, there's heads, tails, and tails, heads. There's actually 2 options that you could do that out of 4, and that's going to reduce to 1/2. What's the probability that you win twice? Well, remember, you win if you get a heads, so here you're winning twice, and that's only 1 situation out of the 4. And if you add up 1/4 and 1/2 and 1/4, that actually does add to 1. So that is what we should be getting. Well, let's look at our binomial distribution table here and see if we get those same answers. First of all, let's talk about what these letters mean. It says that N stands for the number of trials. Okay, so trials are how many times you do something. So if you toss the coin 2 times, what's our number of trials? Yeah, it's 2. So in this table, we're only dealing with this section right here. We don't care at all about those. All right, now we're talking about probability, which stands for P here. What's the probability that you get a heads? Well, that's 1 out of 2. That's equal to 0.5. So here on this table, we're going to be looking at the 0.5 section. And this is interesting. This says, hey, if we have 2 trials, what's the probability that you win 0 times, or it happens 0 times? And here's our answer, 0.25. So this is saying we should get 0.25 here because we had 0 heads, right? What's the probability of winning once? That means you had 1 heads. Well, what's the probability of getting 1? You go over here and that's a 0.5. Does that match? Yes, it does. And then what's the probability of getting 2 wins? Well, that would be a 0.25, which we already had here as well. And what do you notice these all add up to? If we add straight down, you should notice that these all add to 1. Add straight down, that also adds to 1. All right, next question. Looks a little bit different because now we are actually going to flip the coin 5 times. And this question is saying, what's the probability that you win exactly 4 times? Well, we're still dealing with heads, flipping and trying to get heads, so probability of that is still 0.5. But like I said, we're dealing with a trial of 5 times, so we actually don't care about anything here, but we do care about this. So what's the probability that you win exactly 4 times? Well, this is definitely getting harder than the last one. We couldn't do this one out unless we really kind of did a huge tree diagram to figure out what the possible combinations are. That's a lot of work. So this table is much easier. So winning exactly 4 times is going to be this 0.156 right there, which is equal to 15.6%. All right, now what's the probability you win less than 4 times? Okay, winning less than 4 times is actually going to be winning 3 times, 2 times, 1 time, or 0 times, right? That would be less than 4. So if you add up all of those numbers, let's see what I got. I got 0.811. which is equal to 81.1%. All right, and then what's the probability you win 3 or more times? And when it says 3 or more, it basically says you need to count 3. So 3 or more would be adding up those percents or those decimals there, and you get 0.499, which is 49.9%. That was certainly a lot easier than listing out all the possibilities that you could have and whether or not they worked. Okay, let's try a different one besides heads and tails. Have you ever played this game? It's like my favorite of all time. It's an arcade game, and you try to land on the right. You guess the color first, and then you spin it, and if it lands on the color that you chose, you get tickets. And obviously, there's less probability if you land on white, so that has a higher ticket reward than if you chose that you thought it was going to land on green. Anyway, super fun. All right, so in this problem, you win if you land on yellow. So let's say that's the color that you chose. And that's a 20% chance, which is obviously 0.2. If you spin 16 times, what's the probability that? Okay, where are we at? We are at 16 right here. It looks like this person, aka me, already narrowed it down to n equals 16. So we're not crossing anything out. We've got the whole table to look at. All right, so what's the probability that you win exactly 9 times? Well, first of all, we gotta make sure we're looking at the 0.2. So I'm looking at this table right here. And win exactly 9 times is gonna be this right here, which is 0.001. Move the decimal 2 places is 0.1%. All right, what's the probability that you win less than 3 times? Okay, well, winning less than 3 times is going to be adding up this one, and this one, right? That would be less than 3. That's the 2, 1, and the 0. So adding those up, I get 0.352, which is equal to 35.2%. All right, what's the probability you win 4 or more times? Well, 4 or more would be this. And you can add all those up, and I get 0.402, and that's equal to 40.2%. Radical dude. All right, Nadia makes 75% of her free throws. Way to go, Nadia. If she shoots 16 times, what's the probability that she? Okay, well, we're at 16 times. Our trial is n equals 16, and we're talking about 75%, which is 0.75. What's the probability she makes it exactly 15 times? Well, I have to kind of follow this, right here. There it is right there. So that is a point, did I have it right? Yeah, I did 0.053, which is equal to 5.3%. Sweet. Okay, now what's the probability she makes it at least 7? Okay, does that mean that 7 works? Is 7 at least 7? Yeah. So for at least 7, we are going to circle the 7. So where are we at again? We're at 0.75. So circle the 7. I think that's 7 right there, right? At least 7, so that would be that all the way up. Okay, so what's that going to be? We're going to add those all up, and we're going to get 0.998. Now you might be saying, hey, Miss Sorensen, I'm in the wrong category. Zutalor. Here we go, right here. Right there. Okay, so that actually, that is still 0.998. All right, you might be saying, hey, Ms. Sorensen, what about this 0.01? Shouldn't that add up to 1? Well, yeah, you're right, but the thing is, basically, these are rounded, so they might be off by a little bit. We're talking about hundredths. So this would be 99.8%. And what about it? What about if does she make it less than 10 times? So less than 10 times is going to be circling the 9. That's less than 10, so that's 0.052 and up. And that's going to be 0.079 when I add up all those values, which is a 7.9%. Okay? All right. All right. We ready to move on? All right. Now I want to combine our knowledge with this idea of probability of at least 1 equals 1 minus a probability of not A. You actually don't have to do it this method, and most students actually don't like doing it this way, but it can be a lot faster. Here we go. College basketball players, on average, shoot free throws at 70% success rate. For the next 20 attempts that you see on TV, what's the probability that these teams will make at least 13 of their free throws? Well, the probability of at least 13 is going to be 1 minus the probability of 12 or less. So I could actually go, remember we're talking about 70% right here, and 12 or less would be this. Okay, so that's 12 or less. And I add those all up, and I actually get 0.227. And so then I subtract those, and I get 0.773, which is 77.3%. You might say, hey, Ms. Sorensen, that seems like a waste of time. Why can't I just do, why can't I just add up all of these? And the answer is you absolutely can, right? That would represent 13, or making at least 13. But the thing is, these two columns that I've just highlighted here, the black and the red, they add up to 1. So if I do 1 minus the black, I get the red, and vice versa as well. So I don't care which way you do it, but you should know that that is a possibility. All right, here we go. Mr. Fournier, he's playing darts. What a guy, Mr. Fournier. If he throws 20 times, okay, notice how our n equals 20 here, and 90% is way over here. All right, what's the probability that he makes at least 4 on the dartboard? We're going to solve this 2 different ways. The first one is 1 minus the probability. Well, what's the opposite of at least 14? Well, that's going to be 13 or less. Right, because isn't 13 not at least 14? Yeah, and less than 13, like let's say 7, that's definitely not at least 14. So that's the opposite. And so this is going to be equal to 1 minus. And 13 or less, let's see if I can find it on here. 13 or less, I think it's just that. Right, the 0.02, and then all the way up is 0. So that becomes 0.002. And that becomes a 99.8% because I got 0.998. All right. The other way of saying, okay, is the probability of at least 14 is just going to be 14 or more. So, right, I would actually go across, find my 14, which I think is this one right here, at least 14. So I can't see. There we go. So at least 14 would be 14 or more. I add all those up, and I also get 0.998 or 99.8%. Now, I mentioned this on the last slide, but sometimes these two answers will be off by 100th, and that's just because of the rounding situation in the table, that they can't show more than 3 decimal places. All right, that's it, folks. We'll be back for the mid-unit review, and I hope you had a great one.